Question 10.27. For the LC circuit in the figure, inductance L is 32.0 millihenry and capacitance C is 45 microfarad. The capacitor is charged to Q naught equals 10 microcoulomb, and at t equals 0 second, the switch is closed. At what time is the energy stored in the capacitor first equal to the energy stored in the inductor? So here in this question, we have an LC circuit that has inductance L as 32 millihenry, which you can write as 32.0 times 10 to the power negative 3 Henry. Then we have the capacitance C as 45 microfarad, which can be written as 45 times 10 to the power negative 6 farad. The charge Q naught, which is also the maximum charge on the capacitor, is 10 microcoulomb, so 10 times 10 to the power negative 6 coulomb. And we need to find at what time t will the energy stored in capacitor first equal to the energy stored in inductor. Now the capacitor is initially fully charged and it has maximum energy before it is connected to the circuit. When it is connected to the inductor with the switch closed, energy is transferred from capacitor to the inductor. Now, as time passes, energy of capacitor decreases whereas that of the inductor increases. But the total energy in the circuit still remains constant, and that is equal to the maximum energy stored either in the capacitor or the inductor. So I can write for total energy as energy across capacitor plus energy across inductor to be equal to UE max, or you can also write this as to be equal to UB max. Now, why are the maximum energy values equal? Initially, when the capacitor was fully charged, its energy was maximum. When it was connected to the inductor, all of that energy was transferred to the inductor when the capacitor got fully discharged. So whatever initial energy capacitor had when it was fully charged has to be equal to the energy inductor had when the capacitor discharged, if there is no energy loss in the circuit. So you can write total energy to be either UE max or UB max. They both will be the same. So I'm going to write UE, which is energy across capacitor at any given instant in time, plus energy across inductor to be equal to UE max. Now we want energy across capacitor to be equal to the energy across inductor. We need to find that time. So I can just write them both to be equal to UE. So UE plus UE will give you 2 times UE equals UE max. I'm writing this in terms of UE max because we have the charge Q and we can find maximum energy using the maximum charge Q. So let's rearrange. I get UE to be equal to UE max by 2. Energy across capacitor at any given instant in time is given as Q squared over 2C. For maximum energy, the same expression will become Q max squared over 2C. Whereas for any other instant in time, I will substitute Q as Q naught cosine omega naught t, where omega naught is the frequency of the LC circuit and Q naught is the maximum charge. So let's substitute that here. QE, I will write Q squared over 2C. This will be half Q naught squared over 2C. Let's substitute for Q as Q naught cosine omega naught t. So Q naught squared cosine squared omega naught t over 2C equals half Q naught squared over 2C. Now we can cancel off 2C and 2C from here, Q naught squared and Q naught squared from here. That gives you cosine squared omega naught t to be equal to half. Now let's take square root on both sides. We get cosine omega naught t to be equal to 1 over root 2. I want to find time t, so we take cosine inverse. Omega naught t becomes equal to cosine inverse 1 over root 2. Now when you're taking cosine inverse over here,
Make sure your calculator is in radian mode.
because omega is also measured in radian per second or just second inverse. So keep your calculator in radian and not in degree mode. And when you do that, you get this to be equal to pi by 4. So omega t is pi by 4. T you can find by dividing omega naught. So pi by 4 into 1 over omega naught. Omega naught for LC circuit is given as 1 over root LC. So let's substitute that. This becomes equal to pi by 4 into 1 over root LC. That gives you the time t as pi root LC by 4. Or you can just substitute the numbers here, it's fine. So let's plug in the values. Pi by 4 into square root. L is 32 times 10 to the power negative 3. C is 45 times 10 to the power negative 6. And when you solve this, you get the time t to be equal to 9.42 times 10 to the power negative 4 seconds. So this is the time at which energy stored in capacitor becomes equal to the energy stored in the inductor for the very first time.